2.61. Okay, it's correct. Okay. So y value will be 2.61. Okay. Now to design that particular rectangular channel or to construct that particular channel, we need the width of the channel and definitely the depth of that particular channel. Okay, maximum depth. Okay, so that why we have calculated 2.61 meter. Okay, so now we are going to substitute freeboard. Okay, that is 25% of y. Okay, as a freeboard, 25% of y plus y. That will be your design y. Design y. Okay, the design depth of flow will be 25% of y plus y. And see how much you got. I think it will be 3.26. Check it once. Okay, how much you got? 25% of y plus y. That will be your design depth. Okay. We got that depth of flow is 2.61. Then we will provide some extra. Okay. Thus, in case if the discharge is more than 20 meter cube per second, then there shouldn't be any overflow. Okay. How much you got that new depth? Or you can say design depth. Okay. So for this particular design depth, you have to find out the width of the channel. Okay. So again, you are going to use that economic condition. Okay. So you multiply by 2 and you will find out the design width. So that which you are going to provide here and the depth you are getting, that 3.26 you are going to provide that particular depth for that rectangular channel. Find out the width of the channel. Okay, so this is the method of economic section. Okay, so we use this method to design rigid boundary channel or you can say non-irritable channel. Okay, next we have another method that is called method of permissible velocity. First we discuss the steps and then we will move on to the numericals. Okay, okay, so method of permissible velocity. Okay, so you can write down the steps. It's very simple. Steps required for designing by permissible velocity. Number one, assume a permissible velocity within a limit of 1 to 0.91 meter per second. Okay, the limit of this is nothing but 0.6. Limit of 0.6 meter per second to 0.91 meter per second. Okay, that permissible velocity also depend on your silt. Okay, next step is to fix the bed slope. Okay, based on the topography of the field. Okay, based on the topography of the channel. Okay, number three, select the manning sand based on the roughness of the bed. Okay, so this number three, you have to take various cross section, and then you have to release some discharge, and then you find out the manning sand. Okay, or if you are it this n is also depend on what kind of material you have used to line that particular canal. Suppose this is your trapezoidal canal, and to line that particular canal you have used brick wall, then your n value will be different. Okay, then to line that canal, if you use a concrete or if you use mortar, then your roughness coefficient will be different. So depending on the materials that you are used to line the canal or to fix the boundary of the canal, your n values varies. Okay, so that is why it is written here. Select the Manning's n based on the roughness of the bed. Okay, so there are already various experiment is already performed, and you have that table also, various table related to Manning's n for different materials. Okay, for different materials you have different Manning's n. This thing is already done by various people. Okay, this is easily available, this part. Okay, next is to find out the side slope for a trapezoidal or triangular, or you can directly assume also one horizontal is to one vertical. Okay, so for the particular discharge, definitely the discharge is already known. Okay, bed slope, we have to fix that bed slope depending on the topography of the channel. Then we have to find out the velocity. Then we have to take the area equation. It's similar to your previous numericals that you have solved. Okay, then we have to ultimately we have to find out the y value. Okay, z we are going to consider 0 for rectangular channel, and width of the channel we are going to consider 0 for triangular channel. If the channel is triangular, then we don't have any bottom width, so we are going to consider 0. Okay, so this expression is nothing but your expression of a trapezoidal channel. Okay, so most likely we always prefer for trapezoidal channel. Okay, then we are using continuity equation, that is nothing but discharge is equal to area into velocity. Okay, then as we have already used Manning's equation, so using that Manning's equation you can find out the velocity. Okay, after calculating y, that slope you can determine by, or you can fix that slope by with respect to the topography of the channel. Okay, and depending on the type of materials that you have used to rigid the boundary. Okay, velocity, if you can find out the area, then you can directly find out the velocity. Okay, so don't worry, we are going to solve one numerical related to this. Okay, then solving 1 and 2 you can find out the b and y similarly, and then we have to provide freeboard. So here, if that flow is less or discharge is low, then we are going to provide 25%, or the discharge is high, then we are going to provide 30%. Okay, or there is another option, we can select in between these two. Okay, if we are not sure that this discharge will be high or low, then we can select a percentage between these two, 25 and 30. Okay. So these are the steps for permissible velocity. So we are going to solve one numerical related to this. Okay. Okay, that numerical we will solve in the next class. Okay. Thank you.